we are three developers that had a chance to work a bit with Kubernetes in the past months. And we made some internal presentations on this, and then we had the idea of joining everything that we got for an introduction to Kubernetes, because now there are buzzwords like Docker, Kubernetes, containers, and all that stuff. So we got the idea to present to the community an introduction to these technologies, because people are usually curious about them nowadays. So Kubernetes, I'm going to present this with two colleagues, Hugo Ferreira and Nuno Costa, and myself, Ricardo Águas. And yeah, let's go to see the agenda. So I'm going to talk a bit about Docker, because not everyone knows about Docker and containers and all that stuff, and so we really need the concept of containers and containerization to understand about Kubernetes. And then please have a little patience with us. We are going to try a new format where we are going to have a kind of a battle between AWS and Azure. Essentially, we are going to have an interaction between one guy trying to do an AWS deployment of Kubernetes and another one doing the same thing on Azure, so that you get the feeling of two major cloud providers nowadays. Okay. So let's go with Docker. So we are going to talk about images, containers, and then the major concepts of containerization with Docker. And then let's try to figure out a bit how it is supported, how the technology works underneath. Okay, so we have an image. If you see your computer, you have binaries, that's software installed in your machine, and then you have, when you run them, you have processes, right? So a process is nothing more than, let's say, a piece of software, a binary running, right? It's the same thing, or a kind of the same thing as you can think about images and containers. So you have an image, we create an image that will be a microservice inside of it, and then we can make it run inside of containers. So for the same image, we can have multiple containers running. Like in the same way, we can have a binary, as a piece of software that we have, and we can have several processes running the same binary. Okay. And if you want a further reading of why all the trend now about containerization and microservices and all of that, and all the advantages that's giving us, please go to the 12-factor app, and it will give you a lot of bullet points, or 12 factors of the advantages of these technologies. Okay. So Docker is used to run containers. So we talked about images and containers, and Docker is the platform that runs those containers. And one of the greatest things here is that containers are portable. So you can develop on containers, generate your images, and the exact same image will run through all your environments. You can have dev environments, test environments, you can have customer trial, you can have production. And one of the main goals is to have the same image, the same piece of, let's say, code that was compiled and built at the same time to run through production without any interference. The only thing, of course, we need to configure some parameters on those, but besides that, it's the same thing. So a lot of the problems that we have going to production with some differences and so on should be eliminated in here. Okay. So, and to create a Docker image, we need the Docker file. And a Docker file, essentially, it's a file where we specify our image. A started image, usually we start from somewhere, like an Ubuntu image, and then we start installing stuff inside our image. Okay, and with that, usually we develop our software, we copy our files for our software inside of it, and we get entry points for it to start, and there we go. We have an image for that, and then we create images with containers with that. Okay. So, what makes this work? Okay. And essentially it's the Linux kernel. This doesn't work natively on Macs, on other Unix operating systems, and I'm not sure, but I think Windows is now trying to support this, okay, or is supporting this. We worked, but I think that it's really on the Windows kernel now as well. But essentially, it's the concept of control groups or C groups. Essentially, it's a concept on the Linux kernel that allows you a lot of benefits, but we are going to focus essentially on isolation. So let's imagine that you are trying to run a process, and the process can see other processes, or if you have a network port, you'll have an IP address and you'll have ports, and every application must choose a different port, right? In this case, each container will have its own network interfaces, meaning that you can have different containers running on the same machine with the port 80. Okay, so they are isolated on network, they are isolated on a file system, so each container will have its own file system. And you can now try to figure out all the benefits of this. It's completely isolated, like I said, and you can move things through all your environments without any effects of anything else on any software that you have installed on a host machine. Okay? So we have a lot of more of benefits, but for the purpose of today, just going with isolation. So containers will share the same kernel. So everything will be running on that machine with that operating system. And so we cannot have a Windows container running on Linux. We must have Linux containers running on Linux. And it will use the same kernel, so it will use the same machine. And so it's direct. And essentially a container will be a process inside of the real machine. Okay? Or of the machine. Okay, so we can see a comparison. So if we go to a VM, for example, a VM, we need to have the infrastructure, the machine, then we have the hypervisor, and then we need to install one operating system for each virtual machine, right? In this case, we have the host operating system, and each container is running, like I said, in the only operating system that there is. Okay, so with this in mind, anyone wants to make any question about Docker and containers before we move on? No? Are we good? Okay, so now we see a lot of bullet points on Kubernetes. Fortunately, they are related to each other, so don't despair with all of these points. Okay, but let's start. Okay, so why do we need Kubernetes? We have images, we can run containers, but we can imagine that we might want to run multiple containers of the same image, and we might also want to have different microservices, so different images running all at the same time. So let's imagine that I have service A and service B. I want to run 10 replicas of the service A and 5 replicas of the service B. Okay, so if I only have Docker, I will need to run each one of those manually. If some images or if some container crashes, I need to boot it up again. I need to manually do everything. So what is Kubernetes? Kubernetes is an orchestrator for this. So it uses the functionality of Docker, of having containers running, and orchestrating as many images of as many containers of a particular image as you want. Okay, so that's how you build an entire system on these technologies. Okay. So for this we need a cluster. Okay, so let's imagine that in Kubernetes we have masters and we have nodes. And in masters, the control plane or the Kubernetes software, it's running and it's controlling everything, and the masters don't run any containers, or essentially, usually they don't run any containers, and they are only for controlling, and they need to be in an odd number, like 1, 3, or 5, because they will need to vote on decisions, and so they need to be an odd number. And then we have nodes, and the nodes, virtual machines or whatever, can be any kind of machine, they will run the containers that we spoke. Okay. Essentially, it's a cluster. You can have as many nodes as you want, as many masters as you want, right? And that's it. We will see, but yeah, a container will run inside the nodes. Okay. Yeah. That's why we see also here. I don't know if you can see, but we have Kubernetes, which is the software that must run in each node for Kubernetes, and we have Docker. Okay. So, like I said, masters 1, 3, 5, whatever, and we need to access our clusters, right? This is just for information. I'm going to go quickly on this, but we need to have credentials to access our clusters. So we have some commands like the get contexts and the use context. So in our kubeconfig file, we can have access to multiple clusters, and we need to select which cluster we want to access at a given time. Or we can have an environment variable pointing to the credentials that we want. Essentially, it's everything secured for the access because we don't want to allow anyone to access our clusters. Okay, that's it. So another concept, namespaces. So we can partition a cluster logically. And usually we use this for different teams can use a different namespace or different. We also used for getting different environments on the same cluster. Usually we pay for the cluster, and we might want to use that cluster to the maximum to save money. And so we can say that I have development environments, test environments, a demo environment, all on the same real cluster. And they are divided by namespaces. And by knowing the namespaces, I can split it. And so my services will only access the other services from the same namespace, okay, or from closest namespaces. Okay, so it's just a logical partition of the real cluster. Okay. Some commands to get. So you'll get used to kubectl, which is the command line for Kubernetes, and then get will. All the kinds of objects we will get through these commands. So we're also going to see what are pods. For now, think about them like containers. And usually you can get all the containers for a given namespace or all the containers for a particular namespace. Okay. So what are pods? Okay. Usually people make some confusion when they start with this. A pod is not a container, but it's where the containers will run with some twists. Pods can contain multiple containers, but those containers must be tightly coupled. So we cannot have, or we shouldn't have, two different microservices running inside the same pod. Okay? So I'm going to present you an example, but let's imagine that we have a service where some piece of software will pull data from somewhere, some files from somewhere, and another part will get us an API for someone or an HTTP server to get access to those files. And one cannot live without the other, so they are tightly coupled, right? And so in this case, we can put two containers inside the same pod, okay? Because it makes sense. All the pods, or all the containers inside the same pod will see each other as local hosts, so they will not be different machines, okay? And so they are very close, and they share the ports. So if one is using port 80, the other one cannot use the same port, the port 80. Like the file system, they will share the file system, okay? Yeah, as another mention, also pods, they have their own IP addresses, and Kubernetes has its own DNS server. So all the concepts that we are going to see here are essentially pods and services and so on. They are represented inside Kubernetes as a DNS entry. That's why you see IPs for each one of those, and you will be able to access them by name. Okay? So So like I said, and the example, as you can see, we can have inside the pods just 2 containers, but usually it's a one-to-one match, probably 90-something%. People will have 1 container inside each pod. Okay. And like I showed before, get pods describe PO. This is not a typo. All the objects in Kubernetes have abbreviations, and for pods you only save 2 letters. But yeah. Also, when you work with Kubernetes, we have 3 ways of giving commands to it to configure the system. You have the imperative commands. Essentially, we are just typing as we go. Like in this example, create a deployment. We are going to see what it is, and then giving a name to the deployment and the image of the container that we want to run there. Okay, so we are specifying all the parameters to run our pods in the command line. But this is not very good because we cannot save our configuration in GitHub or whatever, right? So we might want to replicate this if the system crashes or something. Then we get to other kinds of configuration. So we have the imperative object configuration, which essentially replaces everything or tries to replace everything with that command. So if we try to kubectl create and we specify a file with the objects that we want to create, it will try to create everything from scratch and get the defaults if we don't specify something. If some value is defined by Kubernetes, like an IP address for an external load balancer, if you try to run it, it will fail again, the create command, because that value was already set. Okay, so we need to use the replace commands, and it's also a bit dangerous because you might be replacing some things that you don't want. So essentially it will remove all the configuration that you have at that point and create it again. And so they thought, okay, this is not the best thing that we can do, so we can create the declarative object configuration. And essentially it's similar to the previous one, but we'll try to merge the configurations. So if we create a service, we're going there, and we say that I want an IP to an external load balancer. If I run the command again, the load balancer is there, the IP is there, but I don't specify in my file, it doesn't care. Okay? Everything will work. Okay? So that's why we advise people. It's a bit more, takes a bit more work to get used to work with the apply commands. It's more powerful, but in the end it will pay off. Okay? Okay, so now Kubernetes inside and out. So deployments. A deployment, it's a file or the object where we define our pods. Okay? And we define our pods. We define how many replicas of that pod we want. Okay, so usually we have stateless services, so we can have 10 different containers of the same image running. So let's imagine that we have an HTTP server service something, and I can have 10 different instances of that server, right? If some goes down, I still have 9, and I can recreate another one again. And also we have the update strategy. So there is a new version of our software. We want to roll out the old images and put them the new ones, and there are some strategies. One, of course, is to delete everything that we have and then create the images again. The problem with that is that it's service affecting, right? So we need to delete all the containers and then create them again. So Kubernetes also automatically controls the update cycle. Usually it creates some new pods with the new image and starts deleting the old ones. So 2 + 2 deletes 2 from the previous one, + 2, and so on, so that your service is still running, probably sometimes with less resources, but it's still working. Okay. Every time that we create a deployment, we will create a replica set, and the replica set, it's the object in Kubernetes that will take care of the replicas. Okay. So it will control how many are there and all that stuff. Okay. if we want to roll back, and it's possible to roll back in some configurations, we can essentially say to Kubernetes to get to a previous replica set, and the replica set will have the definition for the pods, and so we're going back to a previous state. Okay. Okay, some commands that you can get there. So you can get deployments, you can get RS or replica sets. You can write it in both ways, and you can see the rollout status. So every time that we are trying to create the deployments, we will get a rollout, and the rollout status will give us the status of it, because it can take a bit of time. Okay. You can go to rollout history. So for a given deployment, I can be on my version 4, for example, and I'm all the deployments before. So if I want to undo something, and because I failed in some configuration, so the image is wrong, the service doesn't boot up, the new pods are crash, and so I'll just undo and get to the previous version, fix it, and then go to a new one. Okay. I can also specify the revision too, so I can keep 2, 3, 4, as many as I want in the past. Okay? So services. So we have deployments, and deployments essentially control how the pods live. It's kind of a management for the pods. It manages the pods itself, they manage how many replicas of those pods, it manages the update to the pod versions and so on. But how do we access them? When we are creating a service, we need to access them. And those are services. Essentially a service, it's a wrapper around the running pods, the running containers, so that if we have 10 replicas, we don't want to choose each one or to which one replica we want to contact. We just want to contact a front end, and it will load balance to each one of the replicas that it feels it's the best one for in that time. Okay, so those are services. We can see that in this example that we have, for example, a service A. Okay, and it's running in only one on one node. This is the symbol for a container, or for a pod, sorry. And we have our pod with our IP address for our pods, and when we have a service A with a different IP address, we have the master that's running it's checking the deployments, all the objects are there. And then we have another example as a service B, which has 3 pods, 2 in one container and another, 2 in one node, another one in another node. And they all can be accessed by one IP address. Okay, so we don't care to which pod it will go. We just contact the service when we are doing some software, and my colleagues will show you an example with that. Okay. How do we say, okay, this service will take care of these pods? It's through labels. So when we create the pods, we specify the labels for that pod. Okay, that's what we see here. Okay, for example, I'm saying that I have a label app that has the value A. And when I'm on the deployments or on the service, I will say, okay, this service will manage all the pods that match app equals B, equals A. Okay, so that's what we are seeing here. So we have a label selector, meaning that my service A will get all the pods that match this criteria. Okay. So you can create pods manually if you like. We don't advise you, but you can, that have those labels, and automatically, if there is a service there that's waiting for those labels, it will start managing it. The problem is this is powerful, but if you start doing some weird stuff, or imagine that you create 2 different services that's saying, oh, I'm going to manage app A, they will try to conflict with the same pods, and all hell can break loose. So be very careful when specifying the labels and what selectors you use in each service. So usually there's a one-to-one relationship. Okay. So like Like I said, it's a logical set of pods, and we can access them as only one place. And there are different types of services. So we have the cluster IP, which essentially that server is only accessible inside that cluster. No one from the outside can access that cluster. We have the node ports, which Kubernetes will open a port in each one of the nodes that are running the containers, and will open the same port in all the nodes. And if you contact any nodes within that port, you'll have access to the service. Okay. After that, you have the load balancer. It's what usually it's used, and so it will go to the cloud provider, and it will create a load balancer on the cloud provider or a load balancer entry on the cloud provider, and it will give you an external IP address, external from the point of view of the cluster. So if you are in the outside, you contact that IP address, you'll have access to the service. Okay. So usually, if you have a front end and a back end application, you don't want to expose your back end application, but you want. If you want someone to contact your front ends, you only expose the front ends as a load balancer, and all the others can be a cluster IP. I'll show you an example with this. Okay, and there's a fourth type, which is external name, and the external name is just if you want to, you don't manage something from the outside like a database or something. You just say, okay, this service will contact this IP address. Okay, so it's something external. Kubernetes doesn't manage, but you can create a service, a name a CNAME on Kubernetes DNS to access it. Endpoints are just the list of IPs for the pods. So every time Kubernetes software is running, it will get the services, and it will know which one of the pods are accessible by that service, and it will have another object which is just a list of IPs. Okay, so if you build a Kubernetes system and you create different pods and you create a service to access that, you will see the IP addresses for all those pods in this endpoints object. Okay, so this is a bit more advanced concept, but we wanted to show you, which is the ingress controller, because it's also helps us to see how services work, like in the example that I gave. So when we are using HTTP, and 90% of the time we are doing HTTP, right? We can have an Nginx, should be a lot simpler for anyone. And this is maintained by Kubernetes, so Kubernetes supports it, but the ingress controller is essentially an Nginx. So we can do all the routing on HTTP to our services. So let's imagine that we have a.example1.com, and on the root we are going to service 1. But if we are going to images, we can go to service 2. Okay, we can have two different microservices servicing them. And the same thing for b.example2.org. We can say that, okay, if I want to serve on service 3 and on service 4 for videos. Okay, so you do all your configuration for the rules on the ingress controller, and it will match everything. Cool thing about this is a lot quicker than the counterpart in Azure, for example. This solves us a big problem on that. And the ingress controller is the only one that needs to be a load balancer of the load balancer type, and all of these don't need to be accessed by anyone from the outside of the cluster, so they can be a cluster IP type. Okay? Questions? No? Okay.
Is Google using Kubernetes?
Google invented Kubernetes. They are using, so Google it created its own platform, and then they open it to the world. That's Kubernetes. I think they still use a version or an hybrid version on GCE, Google Compute Engine or Cloud Engine or something like that. And they are using, but they're very close. Okay.
What is the format of your configuration file?
That's the next slide. Okay, so Just another thing, we can have external load balancers and internal load balancers. So in this case, we have the internet going to the load balancer, which is our IP that we created and goes directly to the ingress controller. But and sometimes we might want to get an application gateway between the internet and our cluster. Okay? So the application gateway will do SSL termination, firewalling, all that stuff. And this means that our ingress controller will not be exposed directly from the internet. It will be exposed only through the application gateway. Okay, so this is the concept of an internal load balancer, where in the previous one, the IP address that controls the load balancer and the ingress controller, it's public, it's accessed through the internet. And this one is only accessed in the cloud provider. Okay, and there are annotations to create like this, but that's the only difference. Okay, for the ingress controller, it's a load balancer service. It will create a load balancer with an IP address for it, but it will not be accessible through the internet, only to the cloud provider.
Yeah. Is it possible to have two Kubernetes managing quite the same things at the same time?
No.
Is it possible to see one Kubernetes to say to another Kubernetes, okay, it's you, now we will manage all the things. I give you the configuration file, and then you will be the new manager of all the systems.
Well, Kubernetes is a piece of software that's running, and essentially Kubernetes is a cluster. So if you have a different Kubernetes, you have a different cluster.
You can have different clusters talking to each other through federation.
Okay.
That's a more advanced topic.
Yeah.
We will not cover that.
Sure.
You could have a multi-region.
Yeah. And for each region, you have one Kubernetes cluster. Okay. Okay. Sorry. Okay. So config maps and secrets. Let's try to make it a bit quicker. So we have config maps. Essentially, we can create config maps. Inside, we will have names and values for the variables. And we have secrets. The difference between them is that secrets are stored encrypted on the machines, and config maps they are not. And on the configuration files, we will be accessing it with this configuration. So, and from config map ref and with the name of the config map that we created, or the same thing for the secrets, and they will be accessed, all the variables inside the config map or the secret will be accessed as environment variables inside our containers. Okay, that's one of the ways, or a very usual way to configure a container. Okay, we'll pass environment variables to it, and with the environment variables, all the software is reading the environment variables and knows how to behave. Okay. There is also another thing that you can configure it instead of getting them as environment variables. You can specify the secrets or the config maps to be mapped as files. So imagine that you have some value, and the value or with that name, it's a blob. So it's kind of big. So you can map them as files instead of environment variables. So it depends on how you'd like, but you can, this is just to get configuration inside the containers, okay? So, the deployment file. So we can see that we have the metadata for it, the name, and then we have the spec. And spec will specify everything for that deployment. And in deployment we have replicas, we are saying 2, so our replica set that is going to be created automatically when we create this deployment, we'll say, okay, I'll manage 2 replicas, and I'm going to have a revision history limit of 2, so I can only go and do a rollout undo for 2 previous versions. Okay, so that's, I'm not, in 2 years I might have, I don't know, 100 deployments, changes to this, I don't want to have an history of 100, right? So we can specify the limits that we can go back. And inside template, we have the definition for the pods. You can specify a pod directly, but the only difference between what you get inside template and the file dedicated to a pod, it's just it doesn't have the API version and the kinds because it's implicit. Okay. Inside of it, we have, in this case, for example, app A, like I told you before. So it's the label that will control these pods. So the deployment will be controlling pods with this label. And then we have the spec for the pods. So we have containers, we name an image, we say, okay, get me the image from Docker Hub, for example, with this version. Okay, so it will get it from there. We have the ports, HTTP and container port 80. And we also can provide environment variables directly here. So every single container, every single pod will have these variables inside of it. If you go to that container and you do an env command, you'll see them together with this. So this piece of configuration would also fit in here. Okay? So different ways of getting configuration data into our pods. Okay? And with our deployments, we want to create a service to access our pods. So it's quite easy. So we have the metadata as well. Service app A, not a great name. So, and it's a notation saying that I want this service to use an internal load balancer. This is for Azure. Each one of the cloud providers have a different annotation for them, but Kubernetes supports all the major ones. And then we say it's a load balancer, so it will create an IP address and one external on a load balancer. We say the selector, so it will match our application our pod that we just created, and we open the port 80 for the service. Okay, and so we have everything running. So just troubleshooting to try to be a bit quick, so we can kubectl logs and set the namespace and specify the name of the pods. And with that, you can see the logs for that pod and for the first container of that pod. And if something is wrong, your application is crashing, go there. You can also run kubectl describe on all the objects that Kubernetes supports, like pods, service, deployments. You see a lot of information about this, all the IP addresses, everything, the DNS entries, so that you can see what's going on. You can also use the dashboards. So Kubernetes has a dashboards. And you can essentially run it by running kubectl proxy on your command line. It will start serving on the localhost 8001, and you just open your browser /UI/. Don't forget the last slashes. At least some versions had a bug. If you didn't have the last slash, it will go there. But I think it's corrected now, but you never know. And after being redirected to something, add another slash at the end, and you have access to the dashboard. You can also install in your machines the Minikube, just to try Kubernetes. In this case, your machine will be master and nodes at the same time. That's why I said there were some exceptions. And you can create services and deployments and all that stuff in your machines just to play a bit with it. And you can also have a dashboard and just run Minikube dashboard. And questions? No? Okay. Yeah.
You showed us the deployment
file.
It was using the declarative format that you mentioned. Yes.
Okay. So this file. Okay, I'll repeat. You're saying that we are using the declarative format. Okay. Yeah. Okay. So I think I missed one thing. I can go back really quickly. Yeah. So this is, or that file is used on the imperative object configuration or declarative object configuration. They both use files. The declarative object configuration, it also works really well with with folders or directories. So you can have a lot of files like those, and you say apply to this directory, and it will apply all the objects inside that directory. And you can also make it recursive. So if you have a tree structure with all the objects, it will go through all the directories inside and apply all the objects. Usually, you can create a file with the deployments. another file for the service, or you can have everything there. The way that you apply or create that configuration in Kubernetes, it's just by reading the file. So we can see that we have create/f, and we pass the file. And the file will be that one. Okay.
And the secrets?
So, yeah.
I don't understand where exactly do you store them. Are they stored on the cluster? From
Yeah.
the file cluster?
Yeah, on the cluster.
Somehow, like,
But they are encrypted on the cluster, so that essentially you pass that information to the cluster, and you say, okay, I want the secrets, passwords, and the value of the passwords, and you don't want anyone to go there and read it. So it will be encrypted on disk, but if you go to the container that is running, you can see it.
Yeah,
Okay.
we'll see that next.
Okay, yeah.
So
Yeah.
everything stored as objects in the cluster. You can export your files that they can commit to version control. You can export as YAML, as JSON, but that's that's your own representation. Internally in the cluster, they are just objects running deployed in whatever internal storage system they have.
you can apply it again.
Yes, we'll show that. Exactly that.
Just your question?
It seems that there is a possibility to have access to the objects via the terminal, and also we saw a dashboard. And the question is it possible to have a view of the hierarchical component, because there are containers into pods, pods into clusters, and so on. And is it possible to have such a list of things that are included inside? And also, is it possible to have a graphical view of the organization of components? It's like cells of a human body, and with graphical drag and drop, give an order to things to go from somewhere to somewhere else. And the third question, I suppose that it's only dedicated to one computer, but you can have many containers and many pods in different physical machine, and you can transfer things from one to the other, and this is probably a possibility that is very useful.
Yeah. Okay, let me try to everything. So for graphical representation, on the command line, if you run kubectl get pods, you'll have the information for the pods, and you can also see where the pods are running, so in which nodes they are running. You will see the services, you can get information of the service, so we can see, okay, this pod matches the labels for this service. You can do everything. For example, if you get the endpoints, you can see the IP addresses for the pods that are running or that service is controlling, so you can see, you can match the IP addresses for the pods. Okay, this service is controlling these pods. You can do, but for a graphical view of the system, go use the dashboard. Maybe there are tools where you can do all the magic stuff out of it, but usually kubectl provides all the information that we need. And if you follow the rule that labels should map one-to-one to services, you don't get lost. It's quite easy. Your last question was, sorry?
My new question is it applicable to mass volume of things? Probably.
Yeah.
What is the limit of volume that we can have? Is there a limit or not?
I think there is no theoretical limit to Kubernetes, so essentially you can add as many nodes as you'd like to the cluster. And so one service, if you can have 10, let's imagine that you have 10 replicas for that service, all the different replicas can be running in different nodes. Or you can have 2 replicas in one node and another replica in another node, and so on. And by accessing the IP address for the service, Kubernetes will handle everything, and you don't need to care about what pod is really executing the job. But you can scale to whatever you want. Kubernetes is really powerful in that.
It's a marvelous tool for security.
It's a marvelous tool for security. There are a lot of things that you need to configure on Kubernetes. Now they are adding role-based authentication.
It's not automatic. When something is going wrong, it detects automatic and do configuration by itself.
When pods go down, it will do. It will detect you. We didn't want to throw everything, but you have probes where you can check that your services are still running, and if they are not, Kubernetes will assume that they died, and they will create new replicas for it. So Kubernetes will also take care of that. If you're going through security by the thing of access control and so on, they are also adding a lot of stuff like that in Kubernetes, so that not everyone that with access to the cluster can do everything inside the cluster. Okay, so we have role-based access control and all that stuff. But for this introduction, it will be too much. Okay.
Is it protected from that access?
Good question.
Yeah, let's like all services. Okay, so it's running. If someone contacts, I think it's quite robust. But yeah, there is a bug. Someone can get control access to the cluster, right? One more question, so that we can. Yeah.
I was just wondering because you were mentioning the load balancer.
Yeah.
That Kubernetes and the load balancer and everything. But does Kubernetes have a way or a native way, for instance, to handle concurrency between services? Because if you have replicas, they will be doing the same operations. Do you know if there is any way or any native way that it gives you, like, okay, this is
its own load balancer?
No, before the load balancer, let's assume that you have 3 nodes, and the load balancer chooses the first one to do an operation, and chooses the second one to do the second operation.
Yeah.
Both of them access the same resources and eventually write to the same database anyway. Kubernetes gives you like a event bus or something to orchestrate them, or
But you can deploy a container for a bus to handle that. Yeah. So Kubernetes is only an orchestrator for containers. Okay. So. Yeah.
This is just an example to have an idea. If you have a system that is working in the service, and you want to change to another service, you need to change everything, or you can do that byte by byte. Some services in one service, some services in another server, something like that. Is it possible, for instance, to have you decide to change between the Amazon Web Service to
the Google or to Azure?
You have to be big bang change, or you have to change a piece and continue the integrity of the system.
Well, the deployment, all the configuration files are the same for Kubernetes, so they work with the exception of annotations and stuff like that. There are only a few of those. Everything will work in any cloud provider.
But at the same time, part in one system.
But those will not be the same cluster, right? You can have an Azure cluster, an AWS cluster, a GCE cluster, and you can make them work. I think that you'll not be able to join them in a federation if they are from different cloud providers, but I'm sure I never tried that. Okay. Okay. So I'll now pass to my colleagues, and let's see Azure and AWS deployments.
Is it big enough? Can you guys see it? I'll try to explain what Google writes.
Well, first of all, can you hear us? Okay, now we'll try to show some of the concepts that Ricardo explained. Everything we're going to show commands, the demo script of what we are going to execute, preparation steps we did, and all that. It's in this repository, so you can always check it out, see later what we did. I'm going to start with AWS. So it's all nice. We have Kubernetes, but how do we get a Kubernetes cluster? In Google, they do have Kubernetes as a service kind of thing, that you can have managed Kubernetes. You can ask, I want a Kubernetes server. Sorry. You use this one. I'll try to use this one. So now you can So in Google, you can request a Kubernetes cluster, and you have a managed one. AWS and Azure, they are in the process of having that offering, but it's not available yet. It's in beta trials, so maybe around the summer they will have that.
Okay, so for Azure, instead of kops, we have a tool called ACS Engine. And this is just a, bigger? We actually don't have a link, slide with links, but if you want, I can share all these links with you. So this is on GitHub, Azure ACS Engine. This is just a command line tool which generates ARM templates. ARM templates are somewhat of files that Azure Resource Manager can interpret, and you can deploy resources to the Azure without going through the portal and say new virtual machine or stuff like that. So much like we have in the YAML files, we can also have ARM templates for Azure resources. To start, we need an Azure account. So let me just do this quickly. You're going to need...
Just to reiterate, in that repository we have preparation scripts that tell you how to configure an account, and how to configure credentials in the shell to use that account both for AWS and Azure.
I should have done this because we're running short of time, but I wanted to show you what's the difference between AWS and Azure. So in Azure you need an account, you need to log in. I already set up a service principal, and I'll show you after. So with the ACS engine, we need a cluster definition file. And this is just a short version of a bigger file, which has only the things that you want to customize. So in this example, we're going to get ARM templates for West Europe. We're going to say the orchestrator type, it's Kubernetes, because ACS Engine can also run on Docker Swarm and Mesos OC2, I think. We're going to say the DNS prefix. We're going to say the sizes of the virtual machines for the master and the sizes for the nodes. A little bit of configuration also. We also need an SSH key to do so that we can connect to the master, and this is the client ID and secret for the service principal. I logged into Azure so that I can run the AZ command line, but I also need this service principal so that when I try to create the cluster, the Kubernetes can do its own stuff. So this service principal, instead, like when we're going to expose a service with load balancer, what the cluster will do is create a load balancer resource in Azure, and it will create external IPs to it. So this service principal, it's the user that's going to do that. It needs to have access to those resources. So to use the ACS engine, all I have to do is call the binary. There's a lot of stuff here, but what I have to do is generate, and I'm going to do API model, because that's the type of format that JSON file has, and I'm going to point it to the JSON file, which is cluster definition.json. Okay, this is going to create, or is going to. Yeah, there's an iPhone. Sorry. This is going to create a lot of files that I can show you here. Based on the DNS prefix, it's going to create this cube demo folder, which actually reminds me that I have to change something. So demo is the one that we already created. I'm going to do an example here. Okay. So I'm going to regenerate again. And it's going to create that folder, and that folder will have a lot of files. Let's see if it's already here. Okay, so API model. So this is the complete API model file. So this takes all the defaults, the things that we didn't specify in that small cluster definition file is going to be specified here. IP addresses, ranges, version of Kubernetes, number of add-ons that the Kubernetes should have, like the dashboard, sizes for the master, node counts for the nodes, and sizes. Okay. It also generates the ARM templates, and this is just the definition of all the resources that Azure is going to give. This is a big file because a cluster has a lot of resources. Let me just try to close something here. So this is parameters that you can accept, variables, resources, and these are the base sections of an ARM template: parameters, variables, resources, and outputs. So in here in resources, we can see that it's going to have the type of this. It's going to be, so it's going to have all the resources, and I can show you all the resources then. And also the parameters files. Okay, so this is much like a function in its parameters. It's going to have parameters passed to the ARM templates. So going back, I can do ACS. Now I'm going to deploy the actual. Let me just check something. I need a resource group, AZ group, so table. So I have here the resource group, so I can do ACS. Sorry, so I generated the ARM template, and now I can do the deployment. So I can do AZ group deployment, and then pass along, specify which resource group to which resource group it's going to be, and it's going to be example here, which file for the resources, Azure deploy, and then the parameters files, and this is going to be example. And this is it. This is going to go through all the resources and going to start creating everything in Azure. I can show here in the portal. Let's go back, this example. So it started creating some resources, and we can see all the resources that it's going to create. I think this is a little bit faster than AWS, so that's 1 point for me. Okay, but nonetheless, we're going to change to a already created cluster. And where?
I can check how it's going to cost one.
It doesn't get any bigger than this. When it finished, we'll see all the.
Be ready for a while.
Okay. Go ahead.
So anyway, yeah, we can see in the meantime the Kubernetes is created. Regardless, I'm going to switch to the existing one because we can see how that works. So kubectl, I can and the front end one is the same, similar thing.
So now I'm going to follow along
Yeah, so
the same commands.
Can one of you just hold the mic for me? Because he wants to see what I do.
So now remember, we are working on some pre-deployed clusters. At least the Azure one is still deploying. What you can see here on my, so I have an environment variable that points to this file. This file was also generated by the ACS Engine tool, and this allows me to do kubectl, config. If I check the context, it's to that demo cluster that I've previously created, okay? So now I'm going to access that previously created cluster.
Okay. So I'm going to deploy the run app. I'm going to start with the imperative version that Ricardo mentioned. So I'm going to say I want to run give it a name. I'm going to call it back app. I want it to have this image with this version and to be on port 8000 inside the Kubernetes cluster. So what this created was a deployment. It created a deployment for me. And not only created a deployment, so if I check what kubectl, I'm going to ask for deployments, replica sets, and pods. I'm using abbreviations here. Maybe here. No? Yeah, forgot the verb. So I'm going to get these resources. So you can see it created a deployment. Underneath the hood, created a snapshot of the deployment called this replica set, appended this random name, and then created this replica set, generated this pod. And you see there's a family name here on the way it's generated the names for these resources. Now, to access this pod, we need to create a service. So I can do a kubectl and expose the deployment as the deployment called backup. I want to expose it. By default, it's going to create a service with the same name as the deployment. So I'm assuming a lot of defaults here. And now we can check how things are and add the services to see what was created. Sure thing, created the default type of service is internal only, cluster IP. So this service is now available inside the cluster to be referenced by other services. It cannot be accessed by the outside world because it's a service of type cluster IP. Now to access it, we need to create the front app, expose it to the outside, and internally, as you've seen in the code, it can now request the backup. And Nuno is going to show it.
I just screwed up the demo cluster, so I'll have to wait until the new one is created.
For the front?
Yeah,
sure.
Go ahead.
So let's see. For the front app, back app. This is like you just show me a list.
Okay, let me try to catch up.
That as YAML, and I'll see the definitions that are inside. So I see this is metadata, a lot of internal stuff, labels for referencing. This is internal name. So the namespace, again, namespace, there's a default one. That's where we're putting everything. We could customize that. You will see now the deployment has a template for the pods it creates. So because this deployment that generates pods, they will all follow this pattern. Namely, the important thing here is the images they're going to run.
Okay, let me just catch up. So I have the new cluster running. I can do the kubectl run, give it a name to the deployment. The image will be the same, and the port will be this.
Version? You mean version?
No, it will get the latest. So now I can do kubectl get pods. I have a pod running. No, so wrong image. Sorry about this.
Maybe it doesn't have the latest tag.
Just
colon and 0. Put the version.
what?
Just put the version on the.
Yeah. So I'm going to create a new deployment. So kubectl.
In the meantime, just to highlight, I chose YAML as a representation. JSON is also an available one. It shows exactly the same thing. So what type of file you use is not really relevant. So it's relevant what is deployed in Kubernetes.
So would it
Yep.
do something like, would you create your image, your deployment like you did, and then export the deployment straight to Git in this format?
I think we did. I think we did that right on the first time to get some resemblance of a template. Now we just, based on an existing one, we create our all services, the deployments, and all resources on YAML directly. We skip that in version control, and then that's what we roll out to the Kubernetes clusters. So our source of truth is the YAML files on version control. So actually our Jenkins job, what it does when it deploys a new version, is checks them out, replaces the image, and deploys that, and then commits that as a new deployed version.
Okay, so if you look at my screen, the first deployment failed because I had the wrong image name, backup, and now I created a new deployment with backup 2, and now it's running the pod. Okay, so I did the kubectl run. Now I can do the kubectl. What did you do?
Run expose.
Okay, so I'm going to expose a service for this deployment and the name of the deployment, backup. Okay, so if I do kubectl get services, I now have a service for the backup with the cluster IP, no external IP. Okay.
Yeah. So right now we start not having many differences between the two environments, right? Because now we are in Kubernetes level. We are Kubernetes talking to Kubernetes. It doesn't really matter much of the underneath cloud platform that we're using. For the front app, we have here the YAML definitions for front app. So we have the deployment. Similar to what we've seen in the export. Now it's called front app. It has a label called front app. So that it's just like a mirror of the other one. Very minimal set of deployments. So for instance, here we're trying to control the rolling update, how it works. For 1 is a bit useless, but if it was 10, you can say keeping always at least 8 available. So you can tweak all these details of how an application is deploying in terms of what number of the pods supported. On the service side, simpler. You just say it's type load balancer, so you use whatever that type of load balancer the application, the cloud provider gives you, and it provisions one of those. So to use these ones, we use the apply commands that Ricardo mentioned. So we do kubectl, we apply, and kube front. And I'm gonna just do this in alphabetical order. We'll pick up all the files that are in there, and they will just be created on that order. The order is a bit relevant if you want to do this. So if you want to mount a config map in a deployment, it needs to be created first. Because if you're trying to mount something and the resource is not there, it will fail. So in terms of services and deployments, because they are they're not synchronized, their matching is done by labels. If the service, there's no label that refers to it, it's okay, it's just not available to service, and once there's a deployment with the label that matches, it will map to it. But things like secrets and config maps, that are mounted on the image, on the pods, sorry, you need to have them created first in order when you do this bulk creation. So let's see how things are going. kubectl, let's try to describe the service front end. So you can see that it's created, it's normal, and running. It created a load balancer, an endpoint for it. And if we now try to look at, I'm going to steal the keyboard from you a little bit.
Mine's still pending.
Yeah, it's probably still pending. Let me check how the load balancer is doing. Where is it? Load balancers.
Is there any way of checking this progress through Kubernetes dashboard?
No, for the creation of the load balancer. I think so.
Well, I can do a watch kubectl get services, and it will update.
Oh yeah, you're pending. Yeah. Let me do that one. kubectl.
So I can, on my side, I can show on the portal of Azure. And here you have the example. So these are all, can you guys see it? Yeah, it's a little bit, but these are all the services, the resources that the cluster has to have in Azure. So we can, if I search here for type, we can see some disks, we can see the two load balancers. One is for the master, but the other one was created for the service. And if I drill down, it actually has the IP address here. So if I pick this up and I put it here, what are we going to see? Sorry. Yep. Also that. Do I have internet?
Yep.
And this. I still didn't. kubectl get services. Yep, so I got the IP address on port 8000. Yeah, nothing works for me today.
Try to custom
Probably provisioning.
and then right click and paste and go will work.
Well, this one woke up. And this one woke up now. So, but I have the service here. It should be able to. Do you have your IP?
Yeah, I forgot putting the port 8000. That's how we were exposing things.
So, one for AWS now.
So here is the front app being exposed as a load balancer in AWS, requesting this string from the back app, and then just returning as a JSON.
It's warming up.
So we are long
Yeah.
running. I'm going to cut a few things here about upgrading and rolling up, because I think that's a little bit too much. Just show one thing that you can do in terms of operations, like showing the logs of a pod that is running on a cloud service. So if I ask the logs for the back app, for instance.
For the pod.
No, sorry, I want the front app because the back app doesn't want anything. And then these numbers are not correct. Glad the autocomplete takes care of it. It received a request for it, so I could
Descreve já mostraste. Descreve já mostraste. Descreve.
Yeah, that's a short way to describe. So that's the thing, it will show all the logs, I could tail the logs. But then I need to HTTP, for instance. Let's show it again, show it again, 8,000. Not much that it shows, but it's logging. A useful thing is that I can port forward into a pod. Things are remotely, cluster services. They're not accessed from the outside. You might have internal service to debug and to troubleshoot. It's a bit hard to jump into the box. You can port forward into any pod. Let's say I'm just to the back app, which is not accessible from the outside. I'm going to port my 8,000 to the port 8,000 of the pod. And now, for instance, if I request localhost, I get what the backup returns. So although a backup is not accessible from the outside, by just tunneling through to it, I can just interact with the service that is running. And so that's useful for debugging services that are not acceptable. And another thing, I can jump directly into the container. I can execute commands inside the container. So I need interactive, TTI, and I go to the backup, and I want to run ls-l. It shows me the home of the container, or I can just shell into it. And now, I'm inside the container, and I can see all the environment that is provisioned by Kubernetes when it created this container. You can see path. So here you can now explore inside your container with a very easy command without having to know IPs, ports, and things like that.
And for me, just for the sake of it, I'm going to deploy Nginx to the cluster, and then I'll try to do an expose. I can do kubectl expose deployment Nginx. I'm going to specify the load balancer, and I'm going to specify the port. Let's see if this works. So it should be waiting for an IP address now. Here it is, and when we get it, we'll try to see. Because on the other one, I'm getting timeouts. There's something probably that I didn't configure correctly. So just to show you guys that it works. Okay?
And maybe to finalize, I'm just going to kill my cluster, that example that I created. Copy delete cluster. I should have here the name and just check yes. So what this does is goes to that bucket that comes has to put the definition, sees what it created. You're going to check the entire device to see what is there, what was created by him, and we'll just start to roll back everything and delete everything. So it doesn't matter what you have deployed, because you kill the EC2 instances, everything's going to go kaput. And in the end, it will remove things from the S3 bucket. So, easy tool to try. Kubernetes on AWS at least. So easy to create a simple default cluster and delete everything. It will take a while because now there are dependencies in yours to delete. But if you don't have to bother with tweaking all the details of how networking and security works in AWS. You can quickly just start with the defaults and play around. And once you start looking into deploying to production, you can then tweak those settings and go high availability and private zone with a public zone. It has support for all those things. And it kind of wraps up for me in terms of AWS.
Okay, so for me, just to show that I have an IP address and I can deploy some app to the cluster. I also want to mention that Azure has several tastes of clusters regarding Kubernetes. ACS Engine is the one that provides more customability, something like that.
Customizable.
It's more customizable to the user, so you can tweak every single aspect of the cluster. But they also have a managed cluster offering, which is ACS and now AKS, that it's in preview. And with AKS, you don't even notice on the portal, it hides the masters from you. So you don't pay anything for the masters, you just pay for the nodes. So that's a big advantage from the other cloud providers. It's cheaper. There's a lot of links. So ACS Engine here, it's on GitHub. It has a lot. This is the documentation for the cluster definition. Some walkthroughs. There is some examples folder here. And you have the cluster definition files for some base scenarios, something like multiple masters, so you can see where you have to customize the cluster definition to meet your needs. And I think that's it. Let's wrap up. Yep.
Yeah.
We do not have any slide with our contacts, but we are here. If you want, you can ask any questions or reach us, at least through the Meetup website. You can send a message there, and then we can change another way to contact. Well, there is some slides.
Anyway, it's a wrap for us. Thank you for coming. There's pizzas, there's some food, and let's chat a bit if you have any more questions and things to discuss about this.
Yeah,
Thanks.
thanks.